Alrighty. So, yeah, that's squared away. I was thinking about deriving the quadratic formula as a rite of passage for students studying algebra in their first year of looking at those things, and giving it some thought, historical perspective, how important it is, what people think about it. I'm not a big fan of it. Okay, I think it's a mechanical process. I'm not sure students know what they're looking for. Ask yourself, what do you find when you solve a quadratic equation using the quadratic formula? Well, obviously you find the answer for whatever's on the right-hand side of that equal sign. All right, but it's generally found for finding roots quickly and easily. And we've been studying that process now for a couple of weeks. And the rule in my class is if you find an easier way of doing things, you adopt it. We're looking at things from a lot of different perspectives. And so I thought diving into this from the shortcut process to completing the square was useful. And then as I got in it, I remembered my own rule here. If you find an easier way of doing things, then you got to explore it. And so it set me off on another tangent. And I'd like to share some of those thoughts with you and what the ramifications of them are at this stage. I'm not 100% sure, but I'm finding it an interesting exploration. So I want to share with you what I've been thinking about. All right, first off, when my first year teaching here, realized that students had a hard time memorizing things, weren't putting the effort in. So I tried to come up with a mnemonic device. And this is what I came up with. And I want to make sure the whole screen can be seen the whole time here, because there we go. Everything can be seen. Good. I won't have to adjust that again. I do think I'll put the lights on. So give me a moment. See if that helps. Doesn't give her any reflections on the board, but that's what I came up with, was a sentence: don't be iffy, just be squarely, not for certain aimlessness. Pretty corny, but changing the words to symbols, which is really what we do in math. We work with, it's a language, and we're turning all of our thought processes into symbols to communicate quickly. All right, so don't be. So this, remember, we're trying to find equations that solve ax squared plus bx plus c equals anything, but generally speaking, we've been looking for roots. And that's kind of the emphasis on this video as well. All right, and so what do we have for a solution? A pattern. I don't know if it's a pattern, but it's a mechanical process that very easily finds minus b plus or minus, iffy, plus minus, just looks like a square root symbol. B squarely, not for a certain. Didn't have a word for the division symbol. Lessness is a double rhyme. Aimlessness. Okay, so pretty corny, but that's the quadratic formula. And we can see minus b over 2a, our frame of reference, the axis of symmetry of the cup shape graphs. And so therefore our vertex has got to be hiding in there. It's got to be hiding in there. And so I decided, well, let's go play with it and see what happens. All right, so half of you will know how to solve this equation in 5 seconds or less because you put the effort in, and the other half of you are not. So sorry, but for the half of you who 4,7, let's make it -7. So we haven't covered imaginaries yet, and we're gonna this week. We've got to cover imaginaries, and let's say we have an a term of 2, and we want to get a y value of 0. Then I know many of you can write our answers in as quickly as I'm doing it here. Yeah, because you've shown me on test that you can do that, and at the board that you can do that. And so therefore I hope it means a little bit more to you. And for those of you who are hoping to get to be able to do that quickly, if you put this in graphing form, we've got ourselves our minimum at 4, because 0 squared is the smallest square you can get. As a result is 0, and we want -7. And if we set that to 0, I hope you can see subtraction of 7 becomes addition of 7, multiplication by 2, division by 2, squaring is plus minus square rooting, and -4 becomes +4, which is what we had there. So I'm not telling some of you anything new. All right, so I said, okay, quadratic formula. Now we're trying to solve ax squared plus bx plus c equals 0. Well, we need that, yes? Okay, so we need minus b over 2a. All right, well, let's follow what allows us to solve this so quickly. So minus b over 2a is a star. All right, we got to find this y value. Let's put a little star here. And how have we been finding this y value in the ax squared plus bx plus c format? Well, we've been taking the number 4, we've been running it through the equation, right, to get our y value. And so what works with minus b over 2a? Well, we got to plug it in. A times minus b over 2a is going to get squared, and we've got b times minus b over 2a, and we got to add c to find star. Okay, and I'll leave it open bracket for the moment. For problems like 2x squared plus 20x minus 3, let's put that over here just so I won't forget it, because we'll come back to it, I'm sure. It's always nice to see something concrete. All right, well, when we find, put a minus 5 in here, we've looked at just dropping it into the middle term and cutting it in half. And so that's our vertex for that problem. Okay, and for those of you who aren't familiar with what I just did, there's always a 2 to 1. There's always a 2 to 1 ratio at the vertex when you evaluate these first 2 terms, and they're opposite signs. Happens there for a reason, geometric reason. I'm not going to go into that right here. It's not the focus of this video, but it's on previous videos that have been posted. What's going on there geometrically and numerically and otherwise. All right. So I'm not going to take that shortcut here. I think it's more important to, I don't know if I want to say equals 0 here or not. It doesn't matter. So what do we get here? We get squaring a minus becomes positive. You got b squared over 4. I guess I got to do this. B squared over 4a squared. If we're multiplying that by a, then we can cancel one of the multiplications and divisions, and that gets us our first term. Over here, we get minus b squared over 2a. Obviously, we got to multiply by 2 over 2 to get a common denominator. So I am going to rewrite that as minus 2b squared over 4a plus c. All right, so I can erase that, get some more room. So that's minus b squared over 4a plus c. And if we multiply c by 4a, all right, and divide everything by 4a, we get b squared plus 4ac over 4a. And we have just found the vertex. And so that's our vertex. Minus b squared plus 4ac over 4a, which has a lot to do with what we're seeing in the quadratic formula. Right? Because what happened here? We have to change the sign of this. Right? Because we're trying to get to 0, so it's an inverse operation. So we got to change the sign of that when we're solving this for, yeah, let's just go after it. So our x values, 2x values, where frame of reference here is minus b over 2a. We got to change the sign here, and that becomes b squared. Let's see, how do I want to do this? I guess I want it at this stage. Let's just change those signs over to the side. So that b squared minus 4ac over 4a. Okay, so that takes minus 7 becomes positive 7. So that's going to be part of our answer in here. Okay, b squared. I haven't got the square rooting yet. All right, so let's just say that that gets us that number. We still have to divide by a. Now, division by a is the same thing as multiplying by 1 over a. Right? Dividing by 2 is the same thing as multiplying by a half, for instance. So that's going to get us 4a squared here. Okay, and that now gets us the 7/2 process. We still need what? The inverse of squaring, which gets us the plus minus square rooting. All right, And studying square roots, we know that the square root of 4a squared can be written as 2a, and it can be taken outside of the square root, the radical symbol. So that becomes 2a. And then if we have a common denominator, we can express our answer as minus b plus or minus the square root of b squared minus 4ac all over 2a. And I think that's a useful exercise. It was for me. I didn't realize just how much of the vertex was hiding inside that famous formula. Okay, and so again, I don't know how much I'm going to play with that as I move forward with these problems, but I'm going to keep an eye on it and see if it's quicker than this 2-to-1 process, opposite signs. If you plug in your x value of vertex here, and just take the first term, you can change the sign of that and add c, and you're here again. I think it probably comes down to the numbers involved in one of these equations, whether this might be the quickest in some instances. But I think it's probably important to try to get a little better sense of what's going on here. So it's not just a mechanical problem, totally mechanical. And so I hope that in looking at this, that moves the needle a little bit in the direction of deepening one's thought process, looking at it more critically, and understanding what's going on. All right, so I might have been accused there of being redundant in the deja vu department of lecturing, but stop right there.